Hi everyone. So let's continue with the previous video. So let's, in this case, we're going to use a raster file. We're going to read the file using Python, and we're going to plot the data, which is in the raster file, in either this map or this one, this map. So the raster data will be this one over here, which is historical annual temperature. So let's read this one over here, this file. What I'm gonna do is just copy and paste the name of the file. So let's create a markdown cell, reading raster, escape M. Okay, so here, before reading the file, we need to import a library, which is Rio Eds Array. This library allows us to read the file. Let me create, sorry, let's create now, perfect. So if you have this problem over here, so I recommend you to use this cell to solve this problem. So basically you will need to install Rio Eds Array. Okay, so now let's create this variable or in a raster where we are going to use r_eds_r, which is Rio Eds Array. And there is a function called open rasterio, which allow us to read the file. So I need to complete, this is the name of the file, and the extension was TIF. So it was a raster file. I just read the file. So as I mentioned before, this projection meal works with typically works with the WGS 84 projection, which is a 4326. So if we check raster, so Rio, so I get this. So this is the projection. If you have any problem, you will need to with this cell, you will need to install Rasterio. So by using this to solve this problem, if you don't have any problem, so everything was installed when you installed Rio Eds Array. So typically WGS 84 is this projection 4326. If you don't have that projection, if you have another projection, what I recommend you to do is to reproject your raster to this projection. Okay, so now I can quickly shows you what is inside by using by calling the raster and putting plot. So you can see that basically shows the historical average temperature for the US CONUS. And you can see, so what we are going to do, you can see in degrees Celsius. So what we are going to do is overlay this map and try to show the same results, but in this case, we're going to populate these empty spaces by the real world map. Okay, so let's create a new variable called raster, And over here, we are going to call the original raster variable. And okay, just if I copy and paste this one and run it, so you can see that it basically contains one band. This band contains the data, the temperature data, and the array has this dimension, so 400 by 400. So we are going to call one band. Therefore, if I do this, so you can see that basically band 1 disappear. So right now we are just reading that band. So we are inside that band. That's why I put 0, because the index start from 0 here in Python. Okay, so now what we need to do is, so let's plot this. So what I'm going to do is I'm going to use this map over here. So I'm going to Control A, copy and paste this all the way here. But now what we need to do, the thing that we need to do is to create, to put the data that we're going to plot. So over here, so first, let's create let's plot the raster. So first of all, we need to get the x and y values, which is the latitude and the longitude values from the raster. And we need to create like a kind of like a grid. So, and let this base map that will be the grid which will be used to overlay and put all the values, the temperature values. So for this, we're going to use np mesh grid, and this will be so the x will be the latitude values and the y the longitude values. Sorry, the x will be the longitude values, the y will be the latitude values, as you can see in the map. So here and here, west is minus something, so you can see that x contain minus 134 degrees. So over here, those will be longitude values, and over here, the latitude values. So what we are doing is calling the variable, so this variable, the band that we read, and we are getting this. So this is the name of the variable that contains the longitude values, and y will be the name of the variable that contains the latitude values. So in my case, it's x and y. If you have like long and lat, so you should be able to replace x by long and y by lat, depending on what you see over here. Okay, so now that we created like this grid, we should be able to create a new variable called CS, and we're going to call m, so the base map, p color. So this function over here, we're gonna pass the grid values, so x and y that we created. And now we need to pass the data, which is the raster data. So if I just put here raster period data, so it basically takes all the 400 by 400 values. So this is the array that contains all the values. All these values are the temperature. Okay, so now what we need to do is to finalize this. So the C map will be jet. So this is the color that we are going to plot the temperature values. And the alpha will be 0.8, so 80% of opacity. So now one thing here, we are using NumPy. So over here, we need to import NumPy. So what I'm gonna do is over here, import NumPy as NP. Let me run this again. And now let's run this to see how it looks like our map so far. Okay, perfect. As you can see, so we just overlay the map into the base map that we created before. But as you can see, this array it covers the canvas, and the blue values are the non-data, which over here it specified that is, you can see that are the zeros because are in the borders. So values over here, here will be here, and here are zeros. So what we need to do is to replace this by empty, so we can just focus on the canvas, US canvas. In order to do this, so we need to create here a variable, and we need to call raster data, so which will be the array that contains all the temperature values. And now we need to filter. So from this array, we are going to filter the values that are equal to 0 or 0. And we are going to replace those values by, so let's call by empty data, which it will be equal to using the function from NumPy called NaN. So now if I run it, I just run it. So if I rerun and replot, remake the plot, so you will see the difference. Perfect. So as you can see, this is a huge difference. So what we just did was to focus just in the US canvas, the actual values that we have. And so if you have any problem related to that, so you should be make those kind of data transparent by using np period nan. Okay, perfect. So so now what we need to do is, if we go back here, so we have data, which is the temperature values, but we don't have the color bar in this plot. That helps you to understand what means blue, what means orange, yellow, or red. So let's do that. So let's over here create our color bar. So for that, we need to create a new variable called cbar. So let's add the color bar to the base map. That's why I'm using m period color bar. So those will be the values that were used to generate the map. So just put the variable cs, the location. In our case, we're gonna use the bottom, so you can modify this based on the where you want to put it. And let's run it. Perfect. So we get the we got the color bar over here located. However, we have a problem. So as you can see, the color bar is overlaying the labels, the longitude labels. So what I recommend you to do if you have this problem, you can use the parameter PAD, which modify where you can put the color bar position. So I will put it, I will, let me use, 0.5. So you need to take into account that every single time that you're running this, it will take time, because it's not only generating the map based on the resolution that you set here, but also it's reading and plotting and manipulating the raster file that you want to plot. So that's why I'm using the C resolution, which is crude. But if you set this to high or full, it will take even longer. Okay, now you can see I adjust the position of the color bar. So now let's modify and let's add the label. So set label. So it will be temperature, and the units will be degrees Celsius. So let me, degrees Celsius will be this. And let's adjust the font size. It will be, let me use 20. Okay, now before running this, let me add a few things. So the title, so PLT title, it will be the average, historical, annual, temperature. So it will be from temperature from 1975 to 2005, and the font size will be 18. Perfect. So let's run it one more time. Okay, so you can see the title. Those are the labels, temperature. Perfect. So now what you can also do is save the figure. So PLT save figure. Fig. I'm gonna use this name, historical TMP, period PNG, and the resolution will be 300. So now if I go back, so I need to wait for Python to make the plot again. Perfect. So once it finalized, what I can do is go to the folder and I can see the map that I just created. So a few things. So if you want to change this font size and also this one over here, what I recommend you to do is to change everything by using like this code. So let's say if you want to use the same font for every single test, so it will be date. So let's update the parameters. It will be just the font size. Actually, I missed the quotation marks. Font size, and let's replace it by, I don't know, 20. So I need to run these cells, this cell, but also the one that make the plot. Perfect. So you can see that we change all the font size of the test. So what I recommend you to do is maybe to start with to start like replacing the numbers, to adjust the numbers as you saw before. So if I choose higher number, all the numbers in the longitude are going to overlay each other. So let's see, 15 words. Kind of. So what I can do is set this to 12. Oops. Let's say 12. So now you can see that you can see the difference. Yeah, so the numbers increased. By the way, even though you're using this one, so it basically changed all the font size by 12. But if you use font size 20 and so if you specify the font size over here and here, you should be able to take a look at the difference. So those tests, in this case, the title and the label, the color bar label, will be modified to the font size that you specified before. Okay, so finally, if you want to like focus on this area or any particular area, what I recommend you to do is just modify these coordinates. So if you want to focus just in this part over here, so maybe like minus, it will be, okay, let's see. So latitude 60 and 0. So it will be here 0. This one 60. Then it will be minus 40 to minus 60. Sorry, minus 140 minus 60. So now you can see that the map ran faster because the pixel that you're creating are less. All the preprocessing is less in comparison to plotting the whole map, and you can see that we just focus in the area. So therefore, because the image was saved, you can check the image that we just created. So you can see clearly this is the map that we just created. So thank you so much, and I'll see you in our next video.